Okay, we're going to look at another indefinite integral problem. So when I look at this problem, one thing that I notice is that I have a function inside another function. I also notice that I have a quotient here. So we have a quotient rule for derivatives, but there isn't a quotient rule for antiderivatives. So sometimes I have students who try that, but that's for derivatives, not going backwards the other way. But we have two ways that we have been finding antiderivatives in this class. It's either a basic rule that I know and have memorized, or I can do a little algebra to force it into that form, or use substitution. And so there's not really any algebra that you can do to simplify this one, so use substitution is what I would try. So there are a lot of possibilities for thinking through what to let u equal, but if you don't know, the first thing I would try is letting u equal the inner function. If you see a function inside something else, starting with letting u equal that. So I have this natural log of x inside this fifth power. So the natural thing to try would be to let u equal the inner function. If that doesn't work, I might try some different choices for you. All right, so how do I know if that works? Well, I just start by letting u equal something, and then I have to find my du. So the derivative of natural log of x is 1 over x dx. All right, so at this point, this is when I decide whether this u substitution will work. I'm matching up what I have here with all the variable parts of what I have in the original integral. So I have an ln of x here inside that fifth power. That's how I started. And then a 1 over x dx. So it may not be obvious that you have a 1 over x dx, but if you think about that this original integral could be rewritten as ln of x to the fifth power times 1 over x. You don't actually have to write it that way, but just thinking through about how you multiply fractions, that it can be rewritten like that, then you can see that you do have the 1 over x dx. So as long as all the variable parts are accounted for, then your u substitution will work. Remember, if you have extra constants, you can multiply or divide by those to simplify that with the du. I don't have any in this problem, though. So I'm just going to go ahead and do the substitution. ln of x is u, so I'll have u to the fifth. And then in place of the 1 over x dx, I will have du. Right? And then this is just a basic antiderivative rule that you know. So we will have 1/6 u to the sixth. Don't forget the plus c. And then don't forget to back substitute in. If your problem starts out in terms of x, you need to make sure that your answer is also in terms of x. So in place of the u, I'm going to put what the u is equal to, ln of x. And that will all be to the sixth power and a big old plus c at the end. All right, try some of these homework problems.